it's my very great pleasure to welcome you here to actually see what's going on. We've been talking about this and planning this operation for, it feels like, quite some time now, and there's nothing more satisfying than seeing drilling going on, and as you'll see today, to see the products of that drilling, so we can all see that something is actually starting and the project has got going. But what I want to do before we start talking specifically about the UK Geoenergy Observatories is just to say a little bit about what is so important about the subsurface. We're very, very good as citizens, ordinary people, at taking for granted what's beneath the surface. So I often give a talk where I say, well, whenever you go to your local supermarket to do your weekly shop, you're going to one of the biggest mining companies on the planet, because everything that you buy in that supermarket has come from something from underneath the ground. We're seeing in this country at the moment a resurgence of mining activity. Now, normally, when I say that, I'm met with howls of horror and arms going up in the air. But if I go on to say that we've got a mine that's being built in Yorkshire in the national park, it had planning permission to be put down in a national park. It's a mile deep when it's finished. It's being built. It will take a couple of years to get to that depth. It will produce, it's planned to produce 20 million tonnes a year of fertiliser for 100 years. And none of that will ever see light of day in Yorkshire unless they buy it, because it's going by underground railway from underground facilities in the mine to Teesside, where it will be exported. That's a third of the current production globally of this material. So we'll have one mine in this country that is globally dominant in fertilisers, selling fertiliser materials. And that's just one. There are other ventures going along at the same time. What's really important about all of these activities is that while we're very happy to be consumers and to buy their products, which ultimately come from them, we still need to bear in mind that this is a crowded country and we're mining in a crowded country, whatever it is we're going for under the ground. So we have to have permission. We have to see that there's a proper process by which the companies that invest in the production of these materials can be given permission to work in a way that's acceptable to everyone. And that's really, really important for us to get right. We've obviously got experience of that in our plans for the holes that you're going to be looking at today. So for us, as scientists, it's really important that we understand what is going on beneath the surface when we design and engineer operations to go into the subsurface and to extract the wealth that lies within. And we've got to make sure it's done safe, and we've got to make sure it's done in a way which doesn't threaten anyone's health or happiness and anyone's prosperity. So it's a really important thing to observe what's underneath the ground. Put in the context of pounds, shillings and pence, you can see that in this country a survey of the value of mined products to the economy is £235 billion, and that's 12% of GDP that would stop if mining stopped in this country tomorrow. So without any exports, without any imports, without any other trade, that is the value of wealth that's created in this country from mining within this country. And that's, putting it into context, shows that actually we depend upon it very largely. It's 3 times the NHS budget and so on. Now, there are new uses for the subsurface that are becoming more and more important. We need to move away from burning petroleum. We need to move away from burning fossil fuels. We need to recognise the value of those materials as raw materials to be used in manufacturing. So for energy, what are we going to do instead? The great challenge that we have is to take all that knowledge that's been generated from oil and gas and take it across to geothermal, so that we can run with geothermal energy as one of the prime targets of the future, given that it is a carbon-free source of energy. And in the transition to that, we're looking at methane as a possibility as well in other parts of the country. So geothermal energy is the one we really want to get to, and that's the primary purpose, as you will hear, of what's being done here in Glasgow. It's looking for geothermal energy, hot water coming from the inside of the earth that we can use to heat people's houses. We're also interested in energy storage. What can go up can come down, so it is possible for us to put heat from the surface into underground stores and take it back out again when we need it in the winter. So the hot summers could be captured to some extent, put underground and then pulled out again when we need it in the winter. And carbon capture and storage, There are many, many ways in which we can put carbon dioxide from the atmosphere into the ground to reverse the process of burning fossil fuels. And each of those has its own particular characteristics. It could be done in the soil at the surface, or it could be done in old coal workings, it could be done in old oil wells. But we need to have the knowledge to be able to know how that would work as a process. So carbon capture and storage is a really important part of the knowledge base that we need to learn from underground observations so that they can be designed into future operations at whatever turns out to be the best location for that. So in this country, we've been mining for 2,000 years. The Romans, and even before the Romans in Cornwall, they were trading tin to the Phoenicians. And that's led to an evolution of the way in which we control mining. There is an equilibrium between the needs of business, the needs of government, the needs of environmental agencies to protect the environment. And those all work rather well, believe it or not. I mean, there are points of conflict that come along from time to time, but to generate that 12% of GDP shows that we've got a system that works and is able to keep the British economy going. So we want to maintain that lead. Britain has a strong lead in this if you look globally at what is done in other countries. And by enhancing our knowledge of the subsurface and the science of the subsurface through activities like the Geoenergy Observatories, we can maintain that lead and we can build that lead and we can make sure that people come to Britain to buy our knowledge to be able to take on. The scientific evidence is vital for this. As I say, the Geoenergy Observatories are a vital piece in that jigsaw. Thank you.